Yeah, okay. That's what it's supposed to say. Hi, I'm Bruce Gray. I'm util online. We got power up front if you need it. This is sorting whatever star in $lang or sorting anything in different languages. It's inspired by Tom Christensen's old Far More Than You Ever Wanted to Know About series. By the way, I'm listed for some reason as a highlighted speaker, or what did they call it? Anyway, this is not a highlighted speaker level talk. You're going to see some stuff that's out of order. It got moved up by 24 hours. It's not up to my standards. It still has a ton of stuff that I think you'll find helpful or at least interesting. And do let me know if I lose volume for any reason. I want everybody to be able to hear me very comfortably. This talk will be mostly in Perl and about a third in Raku, and just a little bit of mention of Python. Most of the concepts work in every dynamic language. A lot of the concepts work in every language, period. So it ought to be worth seeing for just that. And even if I was giving this at a Raku conference, I would still be covering a whole lot of the Perl, because all the interesting stories about sorting come from the Perl development of sorting. And to really appreciate what's going on in Raku sorting, you need to have a little bit of background in how Perl did it, because that's where it was born from. This stuff is what I'm not covering. The stuff you learn in college, it's hard to get efficient. It's hard to get it correct. It's a maintenance nightmare. And somebody already wrote it. So this talks about the 1% that wasn't already written, the 1% that you have to deliver. And that's what that cool graphic was earlier. If you want to get into the details of bead sort or any of that stuff, Rosetta Code has it in like every language. I'm not going to go over locale or collation because it just doesn't come up in my world, so I don't know enough to speak on it. But especially if you're in a different language, it might be relevant to you. And Perl does support it really well. I just don't know it. As the synopsis said, this is like 6 one-hour classes that have been compressed into a 45-minute talk. So I can't get in depth. It will require some practice on your part to master some of the techniques I'm going to show. But vaguely, or broadly, the comparators, the really important part, where it can go wrong, sorting in Perl, including some advanced stuff, sorting in Raku, Q&A, and if you don't have enough questions, then I'll hit you with how to know and what to do about not sorting. And this is supposed to have a smattering of really cool stories. I didn't do all the research that is needed to be authentic historian kind of thing. So it's going to be storyteller mode, mostly probably true. So a long time ago, I was trying to teach myself C. And I had to do a sort, and that was in the man page. That was in the man page, except I've expanded it. This is easier to understand than what's actually in the man page. Now, those first 3, that's just the C way to say, here's what my array looks like. Here's the input. That one, I just gave up and wrote my own sort and got it wrong. In C speak, what this is a pointer to a subroutine that takes 2 inputs, just generic pointers to anything, and it returns an integer. Isn't that just completely clear? We need to get more basic. The way sort works when it's already written and it's just asking you for your little 1% is it's going to give you 2 items of your data at a time and ask you a question. And the whole sort will just magically work. Well, it's not magic. by you repeatedly answering the question, what's first? If you're sorting cars by color, which color comes first? Well, we don't even know yet. But if we did know, like, how would we answer that? So there's three parts. How are they going to ask us? How are they going to give us two things? How are we going to figure out what the answer is? And then what is it expecting? What's the API for us to answer? The answer is the world standard, -1, 0, or 1, as you all could have guessed, right? But if the first thing comes first, if the first thing it gave you of the two is supposed to be first, if it's in the correct order, you return -1, which is counterintuitive to me, but that's how it is. If they're out of order, then you return 1. And if they're a tie, if that comparator does not inform the order, then you return 0. Simplest case to look at is, got that out of order. Don't have that slide, is strings. Nope. Bear with me for this part. So how do we answer the question in general of what comes before? Well, if you're just talking about strings, then it's that last column. We have operators that tell you exactly that thing. Less than, greater, that's supposed to be greater than, not greater than equal, or equal. So all we have to do is write code to do that first. Is it LT? Then it's -1. If it's greater than, then it's +1. Otherwise, it'll be 0. And we also have in the next to last column, the numeric version of that. A lot of languages have one operator, one set of operators for this, and it's type dependent. The type responds to correctly. In Perl, I think wisely, it really does work in real life. We have two sets of operators. Notice the ones on the far right are letters because they apply to strings. The ones, the numeric ones are symbols that we associate with math. So that's how you know those are the ones for the numbers. Why do we need that, especially in sorting? Because even if you're in just a string, 7's greater than 8 and 8's greater than 9, 9's not greater than 10 because 9 is not greater than 1 and strings are left aligned. This is, you've all seen this on the internet, stuff that goes wrong along this line. So we need, when we're comparing numerically and we want 9 to come before 10, you need it to have a less than sign instead of a LT. And by the way, this is great to put in any sort that you are writing a test for. Have a test case with literally 9 and 10 in it to see if anybody ever messes it up 10 years from now and makes it a string sort. So how would we do that to get the -1, 1, and 0? Well, here's a way. If you're used to the ternary, we just do the comparison. If it's less than -1, otherwise, we fail over to if it's greater than 1, otherwise 0. That is a working sort. That will work. But it's non-optimal because you only do one compare if it is less than. Otherwise, you have to do another comparison. What we would like is to do one comparison that can tell us. That's tricky because less than, greater than, all those things answer with a Boolean. It's true or false. There's no room for a third option. So Perl does have an operator, CMP, that does what we want. It does one comparison. How? Booleans only have two values. Well, because CMP returns literally -1, 0, or 1. Which coincidentally is exactly what we need for a sort. And notice in the upper right corner, I should really be doing this instead of pointing. We call that the spaceship operator. And it is literally the other symbols combined, except you take out one of the equals. So we call it three-way comparison. Numeric is the spaceship three-way, and CMP is the string three-way. And it dovetails perfectly into what we need for sorts. If you run into this before you do sorts, you will be like, why would you do that? That's what it's for. Okay, so how is it going to ask us? How is it going to present those two items at a time? Most languages use just like, you give it a subroutine that expects two things, like I showed you in C, and it passes those two parameters every time. Perl has a high-speed alternative to that. Instead of passing two parameters, it will alias the two items in your array to $A and $B. That allows very high speed passing of this information. And you use $A and $B to answer the question about, are they in order or not? This is the source of our ancient strong teachings of don't use $A and $B elsewhere in your Perl code. We get on to people because it's a natural thing, you just want to sketch something out, $A, don't know, because it can collide with your sort. Also, I've never seen this happen, but it's true, just like in map, you can screw up your data by changing $_. These are aliases. If you do something like $A++ in a sort, not only will you get the wrong answer, you will have changed your original data. And I do make it in my head analogous to map and grep. Map and grep, they automatically alias to $_ whatever one thing it's dealing with right then. Well, sorted takes two things. We don't have two $_, so $A and $B. And this is what it looks like in the real world for the simplest cases. All you're doing is sorting numbers or strings. The top two are numeric sorts reversed, like descending or ascending. The next two are string sorts reversed, or I guess Z to A or A to Z. And that last one, if you really are doing an alphabetical sort, you can just say sort. You don't have to give it a code block. Interestingly, this is one of the stories. If you use one of those four, it works perfectly and it does not actually run the code. Perl is smart enough to detect that you're doing a simple sort. This is from of old, that A, C, and PB turns into the same opcode as just plain sort. And sometime later, but still a long time ago, they added it to recognize that you said A spaceship B and use an internally optimized numeric sort. And then they went further, still a long time ago, like around 5.8, 5.10, and said, if we detect that they've got it reversed, we'll set a reverse flag in the opcode and run the sort backwards. It's so cool that if you do, I gotta quit doing that. If you do this and put the word reverse in front of it, instead of doing this, which would be so much more efficient, you look at the opcode tree and the reverse that would be right there. Oh, shoot. Okay, I will gesture over here. The reverse that you aren't seeing on the second line, it removes it. It has an EX-reverse for this used to be a reverse opcode that I'm now skipping, and it marks the sort to run backwards, which I think is Awesome. I wanted to have a lot more in manufacturer columns, but let's just say, what about those cars? How would we actually use what we've learned so far? I mean, this stuff, all the stuff I talked about before here, this is just the implementation of it, right? Everybody's good with where we are there? But we got to go a little bit further to do our original question about the cars and sorting them by color. We don't, if I just asked you on the street, green or blue, which comes first, I don't know what answer I'd get. But in this program, we're told if it's green, it comes first. If it's blue, it comes second. Otherwise, we just put it in alphabetical order. So I sort by looking up the color of the first one, the number, and the color of the second one. And if it's a tie, then it's going to return 0. And or whether you ignore that dot, I had to do that for code formatting. The OR triggers on failure, on false, on 0. So when there's a tie, it falls over to the next tiebreaker. It's really elegant. You can spell it OR or ampersand, ampersand. So this almost works. You would read this and think it works because I know, because when I wrote it, I thought that worked. But if you got red and mauve and all that, you're going to get color misses, hash lookups will fail. So you've got undef and udef. You all have warnings on, right? Undef will yell at you on every single sort. So we need to condition that. If it's undefined, then I do this all the time. If undefined 0 or undefined blanks, empty string. And that's almost right. But that means that all the colors we're sorting alphabetically they're 0. 0 comes before 1. So we'll get all the unimportant colors and then our 2 important colors at the end. That's the opposite of what we want. So I'll just change that so that my default is whatever's larger than anything I'm using in there. A brief bit on Python. The way sorting really works all the time, everywhere, is it's done in place. You've got your data here. The sort happens here. You lose your original order. If you wanted the original order, you need to make a copy and sort that. That is very efficient and inconvenient. It basically disables an elegant implementation of everything I'm going to show you in a few minutes. And that's the way Python did it for years. Because it's more efficient. Perl and Raku always are streaming mode. It copies it. Okay? You have your input, you have your output. They don't have anything to do with each other. The output is the sorted input. Except the flags I was telling you about, automatically reverses all that. If Perl detects that you are sorting to the same place, that your input's the same as your output, it sets a flag that says, do this in place, and we get it. So later, Python added sorted for a streaming sort, and we always had both under the covers, and you never had to think about it. Okay, stability. Another key concept that for a long time I didn't know I was missing. So substring on index -1 means the last character, so the last single character. I'm going to sort on the last single character. What order do these come out? They have the same last character. There are 2 possible answers. Either they come out in the original order, or you don't know and you are fooling yourself if you think you know. It could be one way this minute and a different way a minute later. If it always comes out in the same order on a tie, that's called a stable sort. It's a property like bead sort and bubble sort. Some of them are naturally stable and some of them are naturally not stable. So in this example, all right, I'll get to that in a second. Quick story. There was a time in Perl where we had stable sorts. And I can't get into the worst case performance and performance curves and all that, but most sorts have a worst case performance on something that you'd have to spend a lot of time to figure out how to give it that data. It just doesn't happen in reality. Perl was using a sort that we abandoned and changed to a slightly slower sort because the one we originally had a worst case performance if it was already in exactly the right order except for the last element, which happens all the time in real life. So we changed it to something that performs a little worse, but is guaranteed not to have a terrible performance like that. And then it was unstable. And so all the people who had always been relying, even subconsciously, on their data being in the right order for ties, it would mess them up. So they gave you control over it. There is an old use sort pragma that says, I want this, I want merge sort, I want quick sort. So you could choose to be slightly faster, but not have stability. And when they first put it in, it was a global parameter. So if you changed it in your program, it changed it for the modules that you're calling. And then they made it lexical. And then several releases went and they said, this is a bad idea, and they took it out. But I'm happy with that because the conclusion is Perl has a stable sort and it is guaranteed by the developers in the documentation. It will always be stable. I have seen one weird downside to stability. If you rely on it to do a double sort. If I want to have all the numbers in numeric order, except I want all the even ones first and all the odd ones next, then that top sort is how I would do it. I ask about its evenness, oddness, compare those, and if they are the same, then sort numerically. You can achieve the same effect with the second sort, which is two sorts. The first sort puts it in numerical order, and the sort above it relies on the fact that it's already in numerical order and just talks about the evenness and oddness. This is inefficient, it is confusing, and it will fool the optimizer. It will no longer recognize that you are sorting to the same place. And this is how you can tell. You can look at the opcode tree. You don't have to have a specially compiled Perl. Perl just comes with this. You can look at your op tree. I've trimmed it way down. The first one says it's in place. The second one has two that aren't in place. It does say that the last one is just a simple numerical, so it won't run the code. It'll just use the optimized version, but that still doesn't make up for the inefficiency of doing it twice. If you want to play yourself with concise, like notice right there, 42 minus 1, what does it say at the bottom? I've got a constant of 41 that I have constant folded. There's some cool stuff under the hood there. And the documentation's on Perl doc. I still can't tell you why it's called B. All the modules for that are like B whatever, but you invoke them with O whatever. Okay, advanced Perl. How am I doing on time? Terrible. Okay, the Orchestral maneuver. How many people know what the Orchestral maneuver is? Just, Show of no. Okay, kind of shake a hand. That helps. Or cache maneuver. when you've got, okay, I don't have the performance curve. I'll have a performance example shortly. One of the things that can go wrong in sorts is you have an expensive calculation in your sort. And how bad is that? If there's a million things in stuff, expensive gets called 21 million times. So we create a cache. I'll just call it H to fit on the slide. And I'll use the exclusive or equals operator, / equals. And what that's doing is, if it looks up in the cache what that expensive operation was on H because it's already been done, then that's all that happens. It does not trigger the expensive calculation. If not, then the expensive calculation is done and assigned to the cache, which is just completely simple once you're used to it and mystifying if you've never seen it before. And in real life, I've got a disk pack that has 8 million files on it. I got a listing of them. And so I just take the first million and I want to sort them by size and get the top one. Sorting by size, getting the size is an expensive operation because it has to go out to disk. It's not already in memory. And when I change it from the simple version of it to the cached version, it goes from nearly 2 minutes to 21 seconds. And as I said, 21 million calculations or 21 million hits on the disk to just the 1 million that would be minimum. The problem that you hit is if I tested it on 1,000 files, you would not be able to tell the difference between those two implementations. They're both sub-second. It's only when you put it in production that it brings the system to its knees. Oh, and why do I need the / zeros there? Because some of the files have been deleted or moved since I did the scan, and so S returns an undef value, and I don't want all those warnings. And just for comparison, if all I'm doing is reading the million file names, it's almost a second of it. Oh, but the downside of the orchestral maneuver, well, the easiest downside is you have to manage the cache. That H, 800 lines down, still has all that memory used up. And so you have to delete it yourself, or you have to know that it's needs to get expired. How far down your program is it still valuable, or is it giving wrong answers if you're going to reuse it? And you may have heard there are only 2 hard problems in computer science: cache expiration, naming things, and off-by-one things. My wife asked me if that was fun. Okay. Pass the orchestral maneuver with ST. If you see ST in a comment about a sort, it's talking about a short-chain transform, which is named for Randall Schwartz, but not by Randall Schwartz. Story for another time. It's from an idea lifted from Lisp, where they call it decorate, sort, undecorate. But Wikipedia and even the Python documentation acknowledge it's a short-chain transform. So here's the idea. I'm going to work from the bottom up. And apparently I need to pick up speed here. You got your data at the bottom. So just value, 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 value. So what's that timing? 10 minutes left? No. What? Okay. I am, okay. We'll do this really, really quick, but this is the important part. Your values, we're going to transform them. Each value will be in a 2-element array. That series of 2-element arrays gets sorted using the key that you calculated, and then you strip out the extra stuff and turn it back into just the original values, which are in the right order. So we're doing a map, sort, map. Whenever you see that, you're looking at the Schwartzian transform. That's what it looks like in the map. I'm looking up the size or 0 and also getting the original data. I sort it just based on the first of those fields. Unfortunately, you have to learn multidimensional data structure syntax, and that's kind of a hurdle in Perl, but it's worth it. It opens up a whole, even ignoring sorting. That's like, I have a talk called The Other Side of the Mountain about that. It'll take you to the next level of your career. And then that last map, I just get the second element. And that runs in 9 seconds instead of 21 seconds. I don't know why it's faster. It ought to be the same speed. There's a very advanced version, very advanced sort called the Gutman-Rossler transform. I'm sorry, Uri Gutman couldn't be here, which I won't go into because we're getting into where you're optimizing for stuff you know about your data. And the stuff you know about your data might be wrong in a year. And you don't have a signal that your sort is now mismatched to your data. You might even get the wrong answer if you've done something very clever, like you always know the last two things. The whole thing will always be in order except the last two things. All you have to do is the last two things. Super efficient until it's not true, and then you have the wrong answer. And somebody buys a company they shouldn't. Okay. Raku. I have to show you a bunch of way cool Raku features that usually provoke enthusiastic questions. And I'm out of time. So please don't ask questions about them until I get to the sorting part or the Q&A. Because they all dovetail, even though they don't seem like they would, into sorting. These are all the parts I'm about to go over. We have context operators. In Perl, if you want to force something into a number or a string or a Boolean, that's the way. You might not have seen that third one. Think about it. That would work. In Raku, we have operators specifically for that. Just put a plus in front of it. You turn it into a number for the expression. It doesn't turn the original into a number. Put a tilde, which is like our dot for a concatenation. String, question mark, is a Boolean. We have in Raku 4 ways to make reusable code. The traditional subroutine, what we call an arrow block, which is actually what you use in a for statement. Placeholder parameters, which is those carets in between the dollar and the letter, and the whatever star. Those 4 create equivalent code. Raku code objects are introspectable. We can ask, what's the arity? Arity is how many parameters do you take? And the answer, if I say, what's the arity and what is the answer if I feed you 8, 9, and 10, for all 4 of those, it's 3 for the arity and 98 for the answer. And so that would be the top callable. That's what we're going to need for sorting. And you can use code, whatever code, block, routine, sub. Maybe you can use method. I don't know how you would. Homing in on the whatever star, you would not actually ever do this. Please don't. I will be angry. That's just for effect. What you really would use it for is like if you had a grep, the star, if it's in a term position, if I've got that right, the syntax can recognize it and expand it into a code block around the expression. So those two bottom lines are equivalent. They are just 2 different ways to say exactly the same thing. You get an arity 1 subroutine where the 1 parameter it takes, it will be assigned to $_ or alias $_. this placeholder version with the carets, like if I said this, that this is a code block that I put somewhere, it would turn it into this subroutine behind the scenes. It takes endpoint and string and says, if I put those in order, endpoint comes first, so it's the first parameter, and it says this is a arity 2 parameter. Can't go into it, no time. Perl has CMP and spaceship operator. Very confusingly, Raku renamed CMP to LEG for less equal greater. So it could repurpose CMP as a generic comparator. So just like in Perl, LEG, or CMP in Perl, and spaceship force you to consider the operands numeric or string. CMP in Raku does not force anything. It uses whatever types its arguments already have. We're going to have a self-mutating method call op, which is actually quite simple. You're used to, if you see that in code, you want to refactor it to that, right? And if you were using Raku code where we use the tilde instead of a dot for concatenation, you would want to refactor it to that. Really, in Raku, every infix operator, everyone that is in the middle and takes two things, automatically has a operator equals version. So, if this is our method call, we want L to be L that is sorted, then I can write it like that. Pardon? Mm-hmm. I do too. I did that. Okay, so let's put all that together into what does our example of our disk pack earlier look like in Raku. Well, I can write it like this. Old style, this is old school style in Raku because it's arity 2. I've got my A and B, but we've got $A and $B now. I could actually use $X and $Y. It's just, as long as they're in order. I treat them as IO objects and I ask what is the size of the IO object. And I didn't put in anything here to handle the zeros because I didn't actually test this. But trust me, it works. It just would warn you. Not the zeros, the undevs. But we don't do this. Oh, well, first, we don't do that because size is always numeric. So I can use CMP. That's why I don't get too uptight about LEG because I don't use LEG or spaceship in Raku like ever. I just make sure that it's the right type for the comparison and I do CMP. But here's the real magic, arity. The compiler can introspect and tell you what the arity is, tell what the arity is of the code that it's called with. If you're using arity 2, you're doing it the traditional way. If you make an arity 1 subroutine, it does a Schwartzian transform or cache or whatever it thinks is efficient behind the scenes automatically. So that's all I need. If you use the dot operator on nothing, it's on $_. The dash is to make it in reverse order because we want it from biggest to smallest. And if I use a colon thing I haven't talked about and the whatever star, then I can abbreviate it even further to highlight the work that the sort's doing as opposed to the assignment of the sort. But let me emphasize, what is that? 7 characters of the real sort? And here's the kicker. CMP, it works differently on different types. We've talked about numbers and strings. If you do CMP on a list, it does CMP on the first elements of the list. And if they're a tie, it goes to the second. If they're a tie, it goes to the third. Which means if I want to have my list sorted by size, and if it's a tie, the modification time, And if it's a tie, then just a simple string sort of the name. Then this is the complete sort. It's just astonishing. I have some further reading there. That one?
Is that creating a hash of the 3 elements?
No. It is a code block that has 3 elements in it, so it's going to be a list, which is a not modifiable, an immutable array is a list. Other questions?
You mentioned a long, long time ago, obviously A and B are aliases, and that we shouldn't change them. Which leads me to ask, algorithms that do change them, it's a very neural network.
Okay. First, I'm going to repeat Bob's question for the camera because I forgot to. He was asking, does this form a hash? And I answered. The question now is there anything where you're using the fact that the aliases are aliases for A and B?
Because you mentioned 21 million comparisons.
Yeah.
That's very linguistic. It's very neural network. You compare nodes.
Can you do something
Set part of A to B part of B.
especially clever by setting part of A to B or B to A? I'll say it's an idea I have not had. It may be a clever idea. My guess is that if there is something clever to dig into there, it would be better implemented without a sort or with something that you're driving a sort. Because what I haven't gotten into is like partial orderings and where you're doing tree sorting. You're essentially constructing a tree in that, and you have to handle that differently. You look up DAGs, the directed acyclical graphs. There's a way to sort those that's just radically different from this. It's like how make works, dependency trees. Does that answer it enough? I know it did. Okay. What else?
So you were saying at one point where with the Schwartzian transform, the map was a lot faster for setting all those hash parameters in cache, right? And what I'm wondering is, could that possibly be because in the first example you had, you were setting the hash params individually instead of all at once by the map column? Is it because of setting all of those little hash params more expensive? I recall at one point that being like slightly more expensive. So I was wondering if that might be the case.
So there's hypothesizing of why we got a speed difference in the orchestral maneuver versus the Schwartzian transform. So I don't know. I will say I'm running on Synology, and I don't know off the top of my head what version of Perl that it's on. I would get, if I, pin me down, I would guess that it's more about memory pressure. But that's very hand wavy. I'm sorry. But if you want to do the experiments and get an answer, I would love to hear the answer. Yes, sir.
Whether you're talking about something like Word or other sorts of sorts, if you have a data structure if I have a data structure that I want to sort relative to another of the same type, and I tell Perl or Raku how objects of that type should be sorted relative to each other, what are your thoughts on that?
Okay, so when we're sorting something particularly complex and we want to define sort order for the complex type. Okay, in Perl, I didn't get into it because I don't favor it for general use. You can write a subroutine that can be called in place of your code block. You have to do it kind of trickily, but it's well documented. And that's what I do in that circumstance. In Raku, we got a fantastic feature that I didn't have time to fit in where you can redefine, you can basically overload the CMP operator for your custom type. And then if everything's well, then you say sort it and it sorts it and you don't have to know anything. There is what I consider a bug right now that I have not reported, because there's some contention of, is it supposed to work this way, where instead of it just working, you have to say ampersand and in square brackets CMP in the sort. And then it magically works. It calls the thing that you've defined for your type. But you shouldn't even have to do that.
I think I have a bug in there. Yeah.
What's your name for the mic?
Joel.
Joel. Oh, masked. I'm sorry. Joelle says that she thinks that she has a bug on that. I'd love to talk to you about that. What else? Because I'm 1 minute over, I'll just say, pardon?
One other question.
Yes.
You mentioned CMP and LG and whatnot. If you were to have strings, string 9, string 10, CMP would still do the right thing sort of numerically.
In Raku? Okay. If Raku doesn't automatically recognize that a string 10, what? Oh, yes. The question is, will Raku's CMP automatically figure out if you're comparing 9 and 10 that you mean 9 and 10 even if it's in a string? No. You have to, that's what those coercers are for. The minus sign, it works just like a plus sign, it just reverses it. So you need tildes in front of it to force it to be string comparison, or pluses in front of it to force it to be numeric. Yes?
Does at least Raku, because I've been looking for this for decades, because it's the real world thing, can I sort the string that contains numbers with the string parts or strings, number parts or whatever?
Okay. In other words, can you sort naturally? In Perl, there is a module that's something like sort : naturally. And you should look that up. And if you find it very useful, you should port it to Raku. If you get the slides, I don't have time, but there are some times where you can be even more efficient. Like if literally all you want is the maximum, we've got something that's even more efficient to just find the maximum, and so on. And you can always ask me about all this. Thank you all.